Good morning. So our group is covering the reverse osmosis process and system, and I'll be covering the theory and system application in this portion. So we start with talking about sodium and chloride, which together form the common known name of table salt. So sodium is a cation and chloride is an anion. When they combine with salt water, there's a problem that's going on within the water that we call ion hydration, which essentially just means that there's a loosely connected ions within the water. The hydrogen, being the cation, then works to loosen up and free up the chloride anion, as does the case of oxygen with the sodium cation. So within the process of osmosis, what happens due to that chemical affinity is that pure water, H2O, will migrate, if we separated salt water and fresh water, through a membrane to ultimately combine. And you could think about this as if you just had a solution of salt water and a solution of fresh water. If you combine them through a piping, what would happen naturally is that the two would mix into a solution, right? So that's a natural process of migration. Ultimately, when the two reach a point of osmotic pressure, we call that equilibrium, and that's where the two become a complete mixture. So if we reverse that process, we have a reverse osmosis process. Again, we just take salt water and a fresh water, and we apply a downward pressure on the salt water. We reverse that going through the semi-permeable membrane, and what do you get is fresh water or distillate on the outlet. And most people think of this only as it applies to water, but that's not the only case. You also find this to happen within the processes of wine, dairy, and maple syrup. Now, it can't only happen through just simply forcing the water through a membrane, because we have to consider the total dissolved solids, or the seawater residuals within the salt water. And that being said, you'll typically find a total dissolved solids of 35 to 40 grams per liter of salt water. So how do we remove that? Well, that's where we talk about the reverse osmosis system. And feed water then will enter through a pre-filter as a low pressure to a high pressure pump, as we described earlier by the piston, passing through membranes which filter out the total solids, coming through my lines here to a common line, back through another set of membranes, and ultimately come out as distillate, which we receive into a storage tank and ultimately send to a treatment and storage for later consumption. Now, because of the pH of the salt water, we typically have to treat that through chemical injection. And you can see that here, that the lines pulled from the outlet of pre-filter are read and adjusted through a chemical injection pump back through the feed water and again back through that system. And as mentioned earlier, because of the total dissolved solids, we have to pull what's called brine, which is typically just about 26% salt within the water, so a heavy concentration of salt water. And that comes out through brine discharge lines, as annotated here, and as well if the distillate gets contaminated, which you can see here at the three-way valve, back into a common line, and eventually sent overboard. And Ms. Geisbauer will cover this on the ship as it applies to specific ship systems. Thank you.
The RO unit that supports the general rider. We're just going to walk through how we get salt water and fresh water. The salt water comes through the supply line located here, and then it goes through these three filters or sediment filters. And then from these three filters, it's going to go to the high pressure pump that's located down here. It's the blue thing. From the high pressure pump, it is sent through the membrane. so it's discharged back into the ocean. Every once in a while, you have to back flush the RO unit to make sure the membranes remain clean. So fresh potable water is sent through this blue filter and then sent through in the opposite direction of normal flow through the membranes to clean them. That potable water is supplied from this potable water line here. And so before you turn it on, you have to make sure all these lines that I mentioned are open. So you have to make sure your saltwater supply is open, brine discharge is open, your back flush supply is open, and then your potable water discharge, it has to be open. Here is the valve for potable water discharge to be sent. If none of those valves are open, if you energize it, you go to turn it on, your earth of equipment or it just simply won't run. To energize the RO unit, you just have to close this breaker located here. Now this front panel that you see here is the control panel for the RO unit. So when it's energized, you can hit start, you can stop it, you can tell it to back flush. It also gives you pressure readings, so you know how the equipment is operating. You also have pressure gauges here on the front and flow meters here on the front to make sure when it's running that everything is running properly.